Hello, my name is Andreas Zegowitz from the Fraunhofer Institute for Building Physics in Germany. Welcome to the first video of the fourth module, where we will discuss the construction overview of INDORE's lighthouse project. The construction method explored is the prefabricated sandwich panel system, and we will look into it through the 6 different mentioned topics in 6 videos. Firstly, starting with the construction overview to create an understanding of the specific building method being used, and then through topics related to the building physics state of the construction, including heat and moisture transport, mechanism, energy efficiency, durability, thermal comfort, and finally, the research overview to give a summary of this module. As mentioned in the first unit, we will focus on the construction system in INDORE, the different materials utilized, and the construction procedures. We will then explore the building physics challenges that might arise from this type of construction. This rendering video shows us what INDORE's lighthouse project, which is yet to be complete, will look like. The project is set to contain a total of 1024 flats. The lighthouse project in INDORE utilizes a hybrid structural system where a engineered steel frame structural system and prefabricated sandwich system are used together. The prefabricated sandwich system, as the name suggests, is a system of panels which are manufactured in a factory and can have several applications such as walls, roofs and ceilings. And in the INDORE project they are used as a walling system. This system provides many benefits, offering speed of construction since the panels are already installed on site, as well as water conservation, as no curing of wall components is required. A lightweight core material is used in the manufacturing of the panels, providing lower loads, resource and energy efficiency, improved thermal insulation and acoustics. To give a brief introduction of the construction process in this lighthouse project in INDORE, it involves the use of combined and isolated footings at the substructure level. At the superstructure level there is a pre-engineered steel frame and deck sheets in the casting floor roof slabs being used. And finally, the prefabricated sandwich panels are used as walls. The steel frame and the prefabricated wall panels can be seen in this picture. The construction procedure will now be explained in detail. Looking at the construction procedure and starting with the substructure. The layout of this site is carried out followed by excavation of each foundation block and leveling by laying Portland cement concrete. Reinforcement for the footings and columns up to the plinth level are then placed, after which concreting is carried out. This followed by backfilling up the plinth, and as can be seen in the picture below, anchor bolts with templates are fixed over the reinforcement of the foundation columns in preparation for the steel frame as it is erected over the blades. Finally, the foundation columns are connected by a reinforced cement concrete plinth beam to ensure monolithic box-like action and seismic resistance. The superstructure procedure then continues, starting with the erection of the pre-engineered building system made up of I sections. They are connected using cranes and through gusset plates, angles, nut and bolts. Once the frame is set up, the process of deck slabs begins, starting with the installation of deck sheets. This is followed by reinforced being laid on the sheets and concreting to form the slabs. Finally, the factory-made wall panels are installed and connected to the steel structure through U-channels and additional clips. In this video we can see how the sandwich panels, which are made of expanded polystyrene cement, are produced in a factory and then transported to the construction site ready for use. They replace conventional brick and mortar walls and can be used for load-bearing and non-load-bearing applications. In these pictures we can see the development of one of the towers at INDORE, starting with the pre-engineering steel frame, followed by the applications of the building. Here we have a picture showing the floor plan of the INDORE units and pictures from a build unit. We will now briefly explore the building physics challenges that may arise from this type of construction in INDORE. The construction challenges that exist in INDORE are manifold. Whether it is the evaluation of materials and their physical properties, whether it is the construction method itself, whether it is the climatic conditions in INDORE. They all have an impact on the heat and moisture transport, on energy efficiency, on durability, or on comfort conditions in these apartments. Within the following submodule, we will address some of these issues and you will learn how to cope with the most pressing of these issues. In the second lecture, you will learn something about the heat and moisture transport. We will have to take a deeper look at the ventilation calculation and the heat bridge calculation. What influence do these effects have? What happens with the heat transfer and how air infiltrates a building? Since we have material with quite low heat conductivity, we will see the influence of heat bridges and ventilation. In the third submodule, we'll take a deeper look at improving energy efficiency in this type of construction. We'll look at the calculation of the heat transfer through ventilation, as well as the influence of a night ventilation to the heating and cooling demand of one flat in INDORE. The measurements needed to evaluate the durability of materials is the topic of the fourth lecture of this module. We will have a look at the special material used in INDORE and how it interacts with moisture and UV radiation. Moreover, you will see how these measurements are performed in an outdoor testing center. Comfort conditions in the flat are the topic of the fifth lecture. You will learn about different methods to evaluate the comfort, looking at one possibility to evaluate the perceived comfort using the PPD and the PMV scale. In the last video, we will have a look at the current research. Many materials are used and procedures declare them as sustainable, but how to evaluate this? We don't know. This will be the topic of the last lecture of this module. Going through this module, you will have a comprehensive overview of these aspects. And with that, I would like to thank you for your attention and say goodbye for this video. See you again in the next videos.